Hi folks, this is 28C on page 84. So they give us this function here which has an absolute value inside an absolute value. So first time we're seeing this, and they're asking us to determine an expression for the derivative of the function and where the derivative is not defined. Okay, so just to get an idea of sort of how this function works, I think I can sketch a graph of this fairly easily. Okay, because let me just take the inside here. So the inside is just absolute value of x minus 1. So if I think of what absolute value of x looks like, okay, it's just this v that comes down, and I'm just bringing it down, so just a vertical transformation by a unit 1 down. So that function looks something like this. Okay, and so here this gets brought down to -1, so this will be -1 and this will be +1. Okay, and then what does the outside absolute value do? It takes whatever is in this interior and makes it positive. So if it's already positive, doesn't change anything, but this section here, it'll just make that negative. So essentially it creates a W shape. Okay, so right off the bat I can determine that, hey, this is not going to be differentiable at -1, at 0, and at 1, because you've got corners at those spots. And we could probably figure out all these different equations, but it's not always quite so easy to draw one of these graphs. So let's see how we would write this as a piecewise function. Okay, so I'll go down here to give myself some room. Okay, but what this tells me is that I'm going to have to deal with this in 4 separate parts. Okay, so I'm going to need kind of big bracket here. Okay, so I know I'm going to have to deal with x less than -1. Okay, so let's start with that. Okay, so let's see what happens. Well, when x is less than -1, that means what's in the interior here is going to be negative. So I have to put a negative in front of it to make it positive. Okay, but then I'm subtracting 1. Okay, but this number now is going to be some number bigger than 1. Okay, because I'm taking the absolute value of something less than -1. When I take when I make that positive, it's going to be bigger than 1. So this whole thing is already positive. So I don't need to change this at all. Now that makes sense, because if you look at this curve, that does look, or this line, this does look like the line -x minus 1. Okay, so now let's go to between 1 and 0. So -1 less than x less than 0. Okay, so x is still negative, so I'm going to have to put a negative sign in front of that first portion. Okay, okay, -1. So again, I put the negative in front of here to make it positive. But now this number is some positive number less between 0 and 1. So when I subtract 1, it's going to become negative. So that means I have to put a negative sign in front of the whole thing. Okay, let's see if that makes sense. This now becomes x plus 1. Hey, that looks exactly like what that segment should be. Okay, so the algebra is is agreeing with what my graph says. Okay, so now let's go from 0 to 1. Okay, so in this case here, x is now positive, so I don't need to put a negative sign in front of that first part. So I can just leave that as x minus 1. But because x is between 0 and 1, when I subtract 1, it's going to make the whole thing negative. Okay, so because of this outside absolute value, I'm going to have to put a negative sign in front of here. And what does that give me? It gives me -x plus 1, which looks exactly like what this segment is. -x brought up by 1 unit. Okay, and lastly, when x is greater than 1, okay, well, this won't change because the x is already positive. Okay, and because this absolute value is greater than 1, when I subtract 1, it'll still be positive, so I don't need to put any negative in front of the whole expression. Okay, and if you look at this, yeah, that definitely looks like x minus 1. Okay, so we were able to determine the graph sort of intuitively, using what we know about transformations, and we were able to figure out algebraically what this function looks like. Okay, so let's just clean this up here. So it looks like it's -x minus 1 when x is less than -1. Okay, it's going to be x plus 1 when negative 1 less than x less than 1. It's going to be equal to negative x plus 1 between, sorry, this should have been 0, between 0 and 1 here. And then it's going to be x minus 1 for x greater than 1. Oh, now speaking of that, okay, what happens when we, with the equal sign? Well, here, when I put, whether it's 1 minus 1 or negative 1 plus 1, I get 0. So I can put the equal sign anywhere. Okay, at 0, whether I have 0 plus 1 or negative 0 plus 1, it gives me the same answer. So I can put an equal sign there. And say at negative 1, well, what do we have? That I have, 1 minus 1 is 0, or negative 1 plus 1 is 0. So I can put it on either one. So let me put it there. Okay, so this is what the function itself is. Let's now find the derivative. Okay, so the derivative of this function, well, let's see what happens. The derivative of the first one is just negative 1. Okay. Okay, the derivative of the second one is just 1. Oops, sorry. It should be negative 1 less than x less than 0. Okay, and then here the derivative is negative 1 again, so between 0 and 1. And here the derivative is positive 1 again from x greater than 1. Okay, but now in terms of the derivatives at these points, negative 1, 0, and 1, I can see clearly that when I approach from the left or from the right, I don't get the same derivative. So that happens at negative 1, it happens at 0, and it happens at 1. So we can say that f prime at negative 1, f prime at 0, and f prime at 1 do not exist. Okay? Okay, and we can give a little explanation here, since derivatives are different from left and right. Okay, and this matches exactly our original conjecture based on the graph.